Hello students, I am Assistant Professor Aparna Kedari. Today we are going to study reagents from chapter 1, that is Fundamentals of Organic Chemistry. Then the compounds that brings about the changes in the substrate is termed as a reagent. For example, in this case, this PCl5 react with this alcohol and it uh, brings changes in this alcohol molecule, that is, it convert this alcohol or it substitute this OH by chlorine and it becomes alkyl chloride, that is ethyl chloride. Therefore, the compound that brings about the change just in the substrate is termed as a reagent. This is the alcohol and chlorination of alcohol by PCl5. When this PCl5 is allowed to, or phosphorus pentachloride is allowed to react with this ethanol, then it this alcohol undergo reaction with PCl5 and it get converted into ethyl chloride plus HCl plus phosphorus oxychloride. Then this alcohol, that is ethanol, is the substrate and this compound, that is reagent PCl5, it brings the changes in this substrate and it gives the product. Then most of the reagents are of two types. First is the electrophilic reagent or electrophiles and second one is the nucleophiles. Let's start with the electrophilic reagents, or it is also called electrophiles. These reagents which can accept electron pairs in a reactions are called electrophiles or electrophilic reagent. These are electron deficient and have attraction for electrons because they are electron deficient species. That is, they are electron loving. They act as an electron acceptor or Lewis acid. They may be positively charged species, that is electron deficient species, or neutral molecules with electron deficient centers. Some examples of electrophilic reagents: the positively charged electrophiles and neutral electrophiles. Here all species have positive charge, that is they are electron deficient. H plus, NO2 plus, Br plus, H3O plus carbocation, that is R3C plus. Some electrophiles are neutral in nature, but their atoms are electron deficient. And sulfur trioxide, boron trifluoride, aluminum trichloride, zinc dichloride, all are neutral electrophiles. They have electrophilic center, that is sulfur, boron, aluminum, zinc. Then next is the nucleophilic reagent. Nucleophilic reagent, also called nucleophiles. These are reagents which can donate electron pairs in a reaction. These are electron-rich species and have attraction for nucleus. Then they attack the regions of low electron density because they are electron rich. Therefore, they attack on the region of low electron density, that is electron deficient centers. They act as the electron donor or Lewis basis. They may be negatively charged species or neutral molecules with lone pair of electrons. Then examples from negatively charged nucleophiles: Cl minus, I minus, Cn minus, OH minus, or carbanion, that is RCH2 minus. These are negatively charged nucleophiles. The next example, neutral molecules which acts as a nucleophiles or nucleophilic reagent is water, ammonia, primary amine, and ammonia. Then in these neutral molecules with electron pair, they have oxygen have two electron pairs, nitrogen have one electron pair. Therefore, they act as a nucleophilic reagent. They attack on the region of low electron density. Then reactive intermediate. Reactive intermediate, in organic reaction mechanism, we encounter some short-lived intermediate or species, and these species are called intermediate. Suppose one reaction is there, A converted into D. Then suppose this A can directly converted into D, or first this A is converted into B, then B converted into C, and then it gives final product D. but sometimes therefore there is two intermediate, that is B and C. Suppose this A first converted into B, then B converted into D. Therefore this B is the intermediate in this reaction. These intermediates are short-lived, and some intermediates are carbonium ion, is carbocation, carbanion, carbon-free radical, and carbons. So let's start with the carbonium ion. An organic species in which the carbon atom has only 6 electrons in outermost shell and carries positive charge because it is electron deficient is called the because octet is not complete, therefore is called the carbonium ion. The carbon atom is in carbonium ion is sp2 hybridized and it has the planar geometry with bond angle is 120 degree. Then carbonium ion acts as an electron deficient species, that is electrophile or Lewis acid. Then this is the carbocation. The carbon in carbocation is sp2 hybridized and its geometry is planar geometry and the bond angle is 120 degree, and this carbon is sp2 hybridized. Then next is the carbanion, an organic chemical species in which the carbon atom has 8 electrons in the outermost shell and carries negative charge is called carbanion. The carbon atom is carbanion in carbanion is sp3 hybridized. It has tetrahedral geometry with bond angle is 109.5 degree. Out of 4 sp3 hybrid orbitals, one orbital carries electron pair and it acts as an electron pair. Then next is the carbon hydrogen. It acts as electron rich species because it is negatively charged, or it is acts as a nucleophile, or it is also called the Lewis base. Then next is the carbon free radical. These species in which these are species in which carbon atom possesses one unpaired electron and it has planar geometry. Then carbon free, this is carbon free radical, and this carbon possess one unpaired electron, and this unpaired electron is present in the 2pz orbital, and this carbon atom is sp2 hybridized. This is odd electron and it is present in the 2pz orbital of carbon atom, and this orbital 2pz orbital is perpendicular to this 3 sp2 hybrid orbitals of carbon, sp2 hybrid orbitals of carbon atom. Then next is the carbene. It is highly reactive intermediate and it is surrounded by electrons and it is neutral. Out of 6 electrons, 4 are used for the bond forming two covalent bonds and 2 electrons are unpaired. These 2 electrons are unpaired. This is the singlet state of carbene. In triplet state of carbene, these 2 electron, 1 electron present in this orbital. It is paired, but it is singlet state of carbene, and there is also triplet state of carbene. In triplet state of carbene, this one electron is present in this orbital. It can have linear geometry or tetrahedral geometry. In linear geometry, when the carbon atom is sp hybridized, and or tetrahedral geometry when carbon is sp3 hybridized. Then